Sir, when we will do grade 11, sir? अभी जो पढ़ा रहा हूँ वो पढ़ो. Okay. हाँ, तो स्कूल में पढ़ो वो. So light. So we go back to our grade 11, 8 level only. We will discuss now. So light is a form of energy. Okay, it's a form of energy. Obviously, we have seen so much of radiations you are getting for light, which can do a lot of things. So as we start understanding light, the first thing that we will try to understand are two concepts. One is known as luminous. Luminous objects. Okay, and the second concept would be non-luminous objects. Luminous. Luminous objects and non-luminous objects. So, luminous objects, listen, okay, try and understand and listen. Luminous objects are those objects which emit light of their own. For example, the sun, then the firefly, it emits light of its own. Okay, stars, every star is a sun, every sun is a star, right? Then a lamp, which is a lit lamp, not a lamp which is switched on. So luminous objects means objects, hang on, the board has now hung up, can't help it. You can write objects which emit light on their own are termed as luminous objects. Objects that emit light of their own. So we can have stars. Out of the stars, the sun is also one of the stars. No. A lit lamp. Okay, a lit lamp. Then we can have the firefly. Yes. Lighted matchstick, but these are better examples, so no one will ask. At the end of the day, if anything, you're getting light from any object, ask the object, do you own this light? Have you produced it on your own? And you only have to answer, because the object is not going to answer. And if you can get an answer that yes, the object produces its own light, like say I have got coal and the coal has been heated. Right now it is in a furnace and it is glowing red. So I ask coal, Mr. Coal, is that light of your own? He says, yes, I am burning to give you this light. So coal, a lighted piece of coal would be considered as a luminous object. Have you understood? And the other part is just the opposite of it. These are objects. Objects which do not emit light of their own. Emit light of their own. Yeah, of their own. Means one thing is for sure. See, to see it in a matured way, both these objects are going to throw light on you. Please understand, both of them are going to throw light on you. Some of them will throw the light which they have generated on their own. Some of them will throw the light which they are reflecting from some source. So non-luminous objects, majority of our examples are non-luminous objects, but there can be some sort of confusion. Like if I ask you, what about a table? Non-luminous. But some confusions are like moon. All celestial bodies like planets, they do not have light of their own. They reflect the light of the sun. Then a turned off lamp. Now this is a very nice example. Now when you see a lamp or a bulb, it can qualify for both the heads, luminous, non-luminous. If the bulb is turned on and it is lit condition, then it's luminous. If the bulb is turned off, then it is non-luminous. Every object will emit light. Now that emit word, as we go in higher classes, we will bifurcate it to somebody will emit, somebody will reflect, and somebody's job is only to transmit. I'm getting from somewhere, I'm sending it somewhere. So whenever light falls on an object, that we will study slowly, you will see a partial portion of that light will be absorbed, some portion will be reflected, and some portion is also transmitted. We transmit light also. It just comes to me and I transmit it. And ask yourself a question. If somebody is producing light of its own, light is a form of energy, then obviously some form of energy must be consumed. Let's look at the stars. They burn a lot of hydrogen to give you light. So there is consumption. The lit lamp is consuming electricity and is giving you light. The firefly has got phosphorus, which is actually burning up and is giving you some sort of glow. Coal is actually consuming its mass, or the energy. In terms of energy, we will say the chemical energy stored in coal is getting converted into glow. So if somebody is producing light of its own, light is a form of energy. Nobody can produce it free of cost. Some form of energy must be consumed and some form of energy has to be converted back. Is this clear? But one thing that we have understood, if we have a source of light, let's say we have a source of light like a sun, and you have any object out here, this, and when sunlight falls on it, there can be three things which will happen. This object will reflect some light, that we will understand what it is. This object will absorb some light, this also we will understand, and this object can also transmit some portion of the light. So this can transmit light, reflect light. This is at a higher level when we understand. Tell me at this level, do you understand what are luminous and non-luminous objects? You do get a question out of it. Yes.
So example darker colors absorb more light.
That is when we study for absorption. Darker colors absorb more, shiny colors will emit more. Okay. Have we understood this? So let's go one step more ahead. Then the daily objects that we see. Now daily objects is also a website now. Daily objects. The daily objects that you see are actually classified under three heads. Maybe NCERT doesn't talk about it here, but must have been talked at a previous class. Transparent. Yes. Then translucent. And then one more we have, which is opaque. Yeah. Transparent are those which do not stop any light and allow majority of the light to pass through. They're going to allow majority of light. Majority of light is allowed to pass. Okay, these are transparent, like my islands, the glass. Have you understood? The islands, the glass, they allow majority. The rain has stopped, I think. Now you can open the window, else it will get hot. Can you? Slowly. Or is it still raining? Okay. So majority of light is allowed to pass through. Majority. So the windscreen of a car, the lens of specs. Translucent, partially. Partially. If you have seen butter papers, frosted glass, bathrooms and all, our friend Yadu is having a bath so that nobody can make a MMS video out of him. So the glass is what? Frosted glass. So once you have frosted glass, you can only see partially. Yeah. And then comes opaque. No light is allowed to pass. No light is allowed to pass. So what all do you have? Transparent, translucent, opaque. Example of transparent would be glass, lenses, windscreens, whatever it is. Okay. Then don't write window, because window is a very vague term. We should write the glass pane on a window. Okay. Translucent. Translucent are the object that allow light to pass through partially. Butter papers, frosted glass. And then comes opaque. So acrylic sheets are also what are known as translucent. These are all acrylic sheets. You have LED lamps inside and these covers are all acrylic sheet. So they also allow partial light to pass through. Curtains, yeah, please go ahead. Mirrors are absolutely opaque. Mirrors are opaque, but they reflect. That we will see later. Mirrors are opaque. Mirrors fall under the category of opaque. Is this also understood? Okay, very good. Let's go to the next section. Our next section would be, how do we see objects? Now, this is just an understanding based on an illustration. How do you see objects? Okay. In order to see objects, we need three things. Okay. You have to have a source of light, number one, because if it's dark, you can't see anything. Then obviously the object that you want to see, that object is necessary. And third, you have to have an observer. Why screen? You have to have an observer, a person who is going to see. Now everything will be based on the alignment of these three things. You need a source of light, right? You need an object and you need an observer. So let's see, how do we see things? So let's say we have a sort of a flower. Okay. We have a flower. And let's make some leaves also on this flower. This is a flower, right? Now, let's also make an observer. So now let's make an observer. So let's say we have an observer out here. And so this is our object. This is number 2. This is number 3. And we should also have something which is known as a source of light. So let's make a sun, which is our source of light. So let this be our sun. Or you can make a lamp also. All means the same. So yes, anyone wants to say something? Have you understood? So the criteria that needs to be met is very simple, that light rays have to come from the source of light and hit the object, and then from the object the geometry has to be such maintained that these light rays should be able to come back to the observer's eye. If this geometry is met, we will be able to see the object, and if this geometry is not met, we will not be able to see the object, no matter how brilliantly the light is illuminated. Let us try to understand. This room is very nicely illuminated right now, right? There's a board behind me, but there is no way that light from the board is able to strike somewhere and is able to hit my eyes, because it's right back, so I can't see the board. However, just understand, if I put a mirror out here, the light from these lamps are going to hit the board, they go and hit back that mirror, and from that mirror it can come to my eye, I can see it. Are you understanding? So it is not necessary that you should always have this, what you call, this flower to be, visible. Say if we would have had an observer on this side, say let's say we have an observer on, let's say we have an observer on this side, and this person wants to view this. Okay, so we can do something like, say for example, we can have a light ray which will go here, and this light ray is from here, will go and say strike a mirror. Okay, we can put, right now we have not discussed mirror, so there would be a mirror like this, and from this mirror you can have another light ray which can go and hit this person's eye, so he will be able to see it. End of the day, remember, the geometry is very simple. Light from the source must hit the object, and the object should be able to reflect light in whatever direction, we don't mind. If that reflection comes direct on your eyes, you can see it. If that reflection is coming via some more multiple reflections, then also we can see it. For example, you guys are all seated behind me, but I can still see some faint images of yours, because light is falling on you, and then it is falling on the screen, which is also working like a partial mirror for me, and I'm at least able to make out by the color of your dresses that there are some people seated. Maybe not that good reflector, it's not that good as a reflector, but it's serving some sort of a basic reflector through which I can at least make out that there are people behind me. Is this understood? How do you see things? Okay, right. Now, obviously, what did we understand? We need to have an object, we need to have an observer, a source of light. Light rays should be falling from the source of light to the object, and from the object it should be again reflected back to the observer, and that is the way you will be able to see. Are we fine on this? Okay. Now, few conceptual things, though whether you was there at grade 8 or not, you should know. Ray of light. Now, this ray of light, this concept itself is an imaginary concept. There is nothing called light rays. This is absolutely imaginary, and this is done to understand. This has been conceptualized by we human beings to understand the geometry, which you will learn in grade 10, the geometry of ray optics. Ray optics means the branch of light or the branch of physics that studies light, and typically light from illuminated objects, right? That is known as ray optics. So to understand ray optics, like if I have a mirror, where should the image be formed? How does a telescope work? How does a microscope work? How do binoculars work? How does a periscope work? In order to understand all those things, we need to understand some ray optics geometry, where there will be a lot of these geometry. There is where you need this quadrilateral and all these items. Okay. Now, that thing is completely conceptual. So to understand that concept, we have put on this concept of ray. Otherwise, there is nothing called ray. For example, if I try to explain that a force is acting on a body, how do we show the force? We put an arrow. Is force exactly like an arrow? No, but that is a conceptual understanding. So a ray of light is an imaginary concept. Remember that this is being put to understand what is known as the geometry of ray optics. And we are studying light here, not by the modern quantum theory of light. We are studying light by the classical Newtonian way. And during Newtonian way, there was something which was known as the rectangular propagation of light. Means, let's understand that. What does it mean? Though a little bit higher than your level, but we can still understand that. We'll try to understand that. Okay. So it's like don't draw. It's just for understanding. So when we start understand light from Newtonian concepts, okay, it's called rectangular propagation, rectilinear propagation of light, not rectangular. The word is rectilinear propagation. Rectilinear propagation of light. What do we mean by that? So light is considered as, it's like a plane. You know what is a plane? A plane is like, assume as if there is a A4 sheet paper out here. So this is one rectilinear frame, one more frame. So light travels as in a straight line. You must have studied that light travels in a straight line, light travels in a straight line. And that's the reason. How do you prove light travels in a straight line? Put an object in the path of light, shadow will be cast exactly in the straight line, which proves light is traveling in a, something must be traveling, otherwise how are you getting a shadow? And that concept is known as the rectilinear propagation of light. It's like rectangles, rectilinear planes are out there. So to understand the propagation, now suppose these rectilinear frames are actually moving from this side to this side. The way we understand this is that you will try to show it with an arrow showing that this is the direction in which light is traveling. This is the direction in which light is traveling. Have you understood what we are trying to say? So light is going as frame. And to show the direction of propagation, we use the concept of ray. And the ray goes by an arrow and by its tail. Arrow shows which side the ray is traveling. Tail shows from which side it is coming. Have we understood this? Okay. If we have understood the concept of ray, we also have another concept of it. From here, we bring the concept of beam. And beam is also imaginary. Beam is a collection of rays. The best example in a desi way, have you seen the sticks that you get from broom? If one stick from a broom is a ray, then the entire jharu or the broom is actually a beam. And our parents used to use the beam to control us or discipline us. Today we gave 5 beams to our kid. And slippers were the best DJI drones, which used to land without any impact. No miss. Target acquired, armed, shoot. So till this place, children, are you fine? Tell me, is there any doubt? What all did we study so far? We started our study with light. We studied what are luminous objects. We studied what are non-luminous objects. Then we studied that objects can be of 3 types, which we can qualify in terms of optics, like transparent, translucent, and opaque. Then how do we see objects? We see objects based on what is the orientation between a source of light, the object, and the observer. The geometry that you have to meet is light rays from a source has to hit an object. From the object, it has to come back to the observer's eyes. If this geometry is met, you see it. And this should not be a direct hit. It can be hit through a intermediate 3-4 parties also can be there. In fact, when you go to a beauty salon, you see everything in and around you, because once you sit in the seat, there are so many mirrors on this side, the other side, behind you. So you see everything, right? Who is walking behind you. And that's a classical example where we say that it need not be that only the light should come to the object and hit you directly. The light can hit many things in between also. Have we understood? Okay. So far, all okay? Okay. Shall I go to the next topic? Okay. Now, our topic of light will hover around one topic which is known as, at grade 8 level, reflection. Reflection of light. Now, again, reflection is a phenomenon which will actually support when we study atomic physics and quantum physics, reflection, because their light is studied as a wave. Waves also get reflected. Have you seen on seashores? Waves come, they hit, they go back. So sound waves also get hit back. Light is also a wave. So light's reflection can be understood from the concept of rays as well as from waves. But now we are kiddos, we will understand it only from the concept of rays. Is this clear? So what is reflection? Reflection means, let's say I have a surface and I have a surface like this on which a ray of light is incident upon. Wait, don't try to write everything. Learn to understand. This is a ray of light. Now, what is a ray of light? As you know, this is imaginary. It only shows the direction of propagation. That means frames of light are coming and hitting this particular object. Are coming and hitting this object. So we say that the ray of light is incident. We don't use the word hit, is incident on a surface, right? It's incident on a surface. And let me name this surface as S. It is incident on a surface S. Now, if this surface has an ability or a characteristic or a property that it is able to send this light ray back to the same medium through which it came, jahan se aaya tha usi mein wapas dhakel diya. So obviously this light ray is coming. We're not considering any, a lot of clumsy examples like water or vacuum. We're simply saying this light ray is traveling in air, and it's come in air and it has hit an object which is, say, S. But the object S has a characteristic through which it can send back. It can send back the light ray to the same medium through which it came, right? To the same medium through which it came. And in that case, we say the ray of light is incident upon surface S. And further, I'm writing surface S has the property to send back. Now, send back. Look, I'm using the word send back, but I'll not like to use the word, although I've written it, but still I'll strike it out so that it is clear to. I'll not use the word send back. We'll use the word which is used, reflect. Yes, this is a better word, okay? So reflect is the better word. So as the property to reflect the light ray back to the same medium from which it came. Now see, surface S has the property to reflect the light back to the same medium from which it came. Then surface S, I will call it as a reflective surface. A concept should be clear. Now, question arises. Do we have a perfectly reflective surface in this universe? No. Nothing in this universe is perfect. Nobody is perfect. That means you cannot have a surface where, say, if 100 units of light rays are coming, all 100 will be reflected back. It cannot be possible, because when light comes and hits as a wave, there will be friction here also. Some heat will be generated here also. As we say, what we say is absorbed. There will be some absorption here also. Some transmission will also happen. But if you consider me as a reflective surface, then I would say what? If a reflective surface means majority, 99.99% of the rays, it should be able to reflect back. Have you understood? So let's understand it once again. If a ray of light is incident upon a surface, and if the surface has the ability to send the ray of light or reflect the ray of light once again back to the same medium from which you came, then in such a case, this particular surface, Ekaksh, this is a class. This is not something where a movie is going on. Get onto your chair and sit on a table and study. This is disrespect. This is the class. This is not that where you lay on the bed and you keep on, rolling up and down and you come. It's not like that. So this is a reflective surface. Then it is known as a reflective surface. Have you understood? Now, if this surface would have absorbed all the light, say suppose we have absorbed all the light and we don't reflect anything back, then I'm an absorptive surface, right? And in higher classes, you will also study about emissive surfaces which can emit radiations when they become heated. So as of now, let's concentrate on the reflective surface. And in the chapter of light, such rays which are coming and getting incident upon, we study them as incident ray. And the ray which is sent back, we study them as reflected ray. And this entire phenomenon, whatever I spoke about, is known as reflection of light. So let's try to understand it in a language of definition. What is the phenomenon of reflection? So we say when light rays are incident on an object and the object has the ability to send the light ray back to the same medium through which it traveled and came, then that is known as reflection. And the object is known as a reflective surface, or reflection is the phenomenon by which you'll get all these definitions in book. Just try to understand. Reflection is the phenomenon by which an object is able to reflect light rays that are incident upon it into the same medium through which they traveled and came. अगर मुझ में वो capability है that I can send the light rays which came and hit on my body back to the same medium through which they came, then I'm a reflective surface. Now the question arises, are everything reflective surface? Now how do you answer that? Is everything a reflective surface? What is not a reflective surface? First, let me understand that. What is not a reflective surface? Answer. You can be wrong, children. This is how we learn science. What is not a reflective surface? Tell me, in and around. In and around, do you see anything which is not a reflective surface? Table. पर ये टेबल को आप देख तो रहे हैं ना बेटा? So you go back to the same definition here. Before you say whether the table is a reflective object or not, go back here. Are you able to see the table? It's reflective. If it does not reflect, then how am I able to see it? Maybe ghost and bhoot, they are non-reflective. That's why we don't see them. And they are like, we are able to see. So what is the thin line difference now? Can you now tell me? Obviously, we have understood. Yes, Sarvesh. Completely black substance we are able to see. Charcoal, blackboard, don't you see? No, why is that? Don't have that broken record like doesn't it have, forget about absorb. To see something, I should have light rays coming from it. So it's reflecting. It reflects. Agreed or not? All objects are reflecting. The question here that you should have answered me, sir, the degree of reflection varies from object to object. Are you understanding? If you are a superbly reflecting surface, then you should be able to see yourself out there. So do you want the world to be perfectly reflecting? No. Then life will become very bad. You will be like the lion in the well story. Have you understood? A lion used to eat one animal every day, right? So this way the jungle, all the animals were very unhappy. So one day the rabbit said, somehow today we need some solution. So the monkey said, I'll make a solution. He took the lion and he said, he went late. It was the rabbit's turn to go, but instead of the rabbit, the monkey went, and he went very late. The lion was furious. How come you're so late? I need my food. He said, I was coming on time. There was another lion who actually stopped me and told me, how dare you go to him? I am the most powerful lion. This lion became very angry and started saying, who is that lion who stops you? Can you show him to me? He said, yes, he's down there, out there. There's a well and he's just living in that well, right down the well. So actually the monkey took the lion to that well. And he said, where is it? He said, your majesty, just look down at the well. So when the lion looked down at the well, what is he seeing? His own reflection. He started growling. The other lion is also growling. He became so angry. He said, I'll eat you later. First, let me finish this fellow. Jumped into the well. And after that, you know the story, that the forest had all the animals very happy because the tyrant was gone. So what happened? If you have everything as reflective around you, then life is very boring. Remember, just think you are just bending your head down to write something on this table, you see your face. You have seen glass top dining tables, have you seen? Okay. So if you have a glass top dining table, the most idiot setup that you can have a glass top dining table and then have a table lamp also. So once you start writing, you will see another table lamp from the bottom and you will see your own head. Don't you think life will be very bizarre? Your copies and everything, if their reflective surface is fully reflective, then you see everything. We don't want that. Glass, mirrors.
For example, light falls on an object.
Light falls on an object. If it is fully reflective, you will see your reflection on that. Light will come back, but you will see yourself also. That's called image formation. 100% light will come back. So, have we understood that? That you'll understand when we. So, is this concept of reflection of light understood by you? What is the phenomenon of reflection? Reflection of light is a phenomenon by which an object is able to reflect or send back the light rays that are incident on it to the same medium from which they came. What we need to understand is that the intensity of reflection or the degree of reflection varies from object to object. Everyone, here we are not questioning transparent, translucent, opaque. A wood is opaque, no doubt about that. But does the wood reflect? Yes, the wood has to reflect. Otherwise, how do you see the wood? So as I told you, the only thing that doesn't reflect are ghost and bhoot pret. Unhi ko hum dekh nahi pate hain. We say, na, we don't see ghost and spirit. So maybe they are not reflecting. Is this much understood? Our next part of the story, yes, keep on telling me, now goes round to the discussion on this area. That is reflective surfaces. And let's try and understand the basic reflective surface that we would like to see. Now, you can now ask me, sir, since you said that the degree of reflection varies from object to object, what is the best reflector? So silver is considered to be the best reflector. Nothing is a better reflector than silver. That's why whenever you have space shuttles, satellites, and all these things which go up into the space, a huge amount of silver is used, because the only type of cells that will work there are what? Solar cells. And solar cells need a lot of sunlight has to be reflected back. So whenever these satellites, after their life, they fall somewhere into oceans and all, they are treasure hunters things. A lot amount of silver will be available. Silver is the best reflector. Is this still this part? We understood? Okay. Now let's go to our next part, where we now try to understand reflective surfaces. And the welcome to the world of the first reflective surface which we'll study a lot, that is known as plane mirror. Now look and observe the spelling. Plane mirror. It is not plain dosa, PLAIN. It's plane mirror. PLANE. Plane mirror means a mirror which is planar in shape. Do you understand what is planar? So how would you best categorize something that is planar or a plane? Take a straight object and see whether you can align that object on it. Another way would be that you have spherical objects. In this, you can't align it. So this sort of mirror means it's a plane mirror. It can be straight, rectangle, paralleloids, or it can be a circle, it can be an ellipse, like you have decorative mirrors in your house. And the closest match to this is the mirror that you every day, or that is a plane mirror. So let's understand how a plane mirror is made. Have you understood? Plane mirror, not plain mirror, plane mirror. Many people write it as PLAIN. No, plane mirror. It is a mirror in a plane. Okay, so let's see how this mirror is made up of. So first understand, a plane mirror is actually a sheet of glass. You can use a sheet of glass. Glass will work the best. Glass will work the best, but this glass should be absolutely plain. Okay, glass will work the best. Many people nowadays, glass is very heavy. So if you look at in Papal City, after say Tower A and Tower B, all the windows that you have are all acrylic windows. Tower C onwards, they are much more lighter. These are lighter. But the windows that we have in our house, in Tower B and all, they're very heavy. They're made up of glass. So glass costing, transportation and all goes up. So you can use acrylic also, but glass would be better. So I would have a slab of glass. Now, this drawing that you are seeing is something like this. This is the glass sheet. This is a glass sheet. And I'm actually showing it to you in this manner. Have you understood? I'll have a glass sheet. Any doubt? No doubt. Okay. Right. Next, what I'll have on this glass sheet will be a very thin. Now, this is the one which will add the cost of this mirror. A very thin, a very thin layer of very high grade reflective material. Very high grade reflective material. Now, question arises that the glass that you have in front of your wash basin, you get the same glass size in various costs. Now you can have Saint-Gobain is one company, Saint-Gobain, Modi glasses, these glasses, a lot of variants available. And you'll see there's a lot of difference in the price also. The same glass can come in 600 rupees, the same can come in 6,000, the same can come in 8,000. What is the difference? The difference is not this. The difference is this blue layer. This blue layer is the reflective surface, and ideally, this surface should be, this blue layer should be silver. Yeah, ideally it should be silver, because you have to have a reflective surface. Glass is transparent. When light will fall on it, it will just pass away. So what we have, and this silver is a very thin layer. Have you seen Kaju Katlis and sweets? On that you have silver foil. It's like that. Many houses, say, if you come down to our houses also, it's like say 13, 14 years old now, slowly you will see the mirrors from the back side are having peeling effect. Have you seen? In some mirrors you will see peeling effect. So it appears as if a foil has curled and moved off. That foil or that curl is actually the reflective surface. You should use high grade silver. Now this is what is going to add up to the cost of the entire thing. If this surface is good, the mirror will last a long time and it will be absolutely quality mirror. And if this is silver, but silver mixed with something not that good quality of mirror, then initially you will see yourself proper, but after 4 or 5 years, as water starts falling and all, corrosion will take place. Okay, after this we will have one more layer, and that layer is known as the red oxide paint. Okay, so have you seen mirrors? The back of mirror is always a red color. So that is the protective paint which we will give, and that is known as the red oxide layer. So this is your protective film. So have you understood? Glass, on back of glass, what should you have? You can even use your mom must be using aluminum foil to pack your lunches. So you can even put aluminum foil without any bent or anything, but you're doing a very cheap quality glass. Still you can see. Not that you can see the eyelashes of Shreyas, but you can at least make out that there is a boy who looks like Shreyas. Because what are you using? You're using aluminum foil, not silver. Okay. So let's start naming these now, or labeling our figure. So this is one, sorry. So we have got 3 layers out here. This is layer number 1. And you know how to draw or label diagram? Everything should be horizontal. Layer 1. Then we have got layer 2. This is our second layer. Anyways, otherwise it will not look okay. So I'm drawing it this way. Layer 1. Then you have your layer 2. And then we have a third layer. So let's label them. This is a glass sheet. Then I have the silver lining. And this is the red oxide. Red oxide protective layer. So if you start scratching this red oxide paint, this is usually a paint, then you are actually gaining access to the silver lining and you will be damaging your glass sheet. So once this has been made, what we need to understand now is that this side of the mirror will be known as my reflective side, and this is known as, in the language of optics, it is known as the polished surface, or we call it the smooth surface. We don't call it the reflective side, we use this word, polished surface. And this one would be known as my rough surface. Rough surface. So this is my plane mirror, but in our optics drawing, we won't have the time to do all these jing bang that we have done. So in our optics drawing, we just make a straight line like this. And the way we understand is, this is called etching, ETA. We etch it on this side. Right? And once we have etched it, then there are 2 sides to it. So this will be my smooth side, and this will be my rough side. Is it clear? Hence for all, I will draw this. Then when we come to spherical mirrors like concave and convex, when we study in grade 10 about all those things, we will be making spherical mirrors, so we will make. Is it clear now? So what is a plane mirror? A plane mirror comprises of a sheet of glass, okay, which is plane in shape, and then it has a fine layer of a shiny, high grade shiny film right behind it, and then that is protected by a layer of red oxide paint. Now if you stand in front of this, then you can see yourself. Okay, and a plane mirror should not show any aberration, means the way you are, the way is what you will see. Is this getting cleared? Okay. Can I go ahead? Okay. Our next thing, before we study about image formation by a plane mirror and its characteristic, we should also understand what we mean by an image. What we mean by an image. So in ray optics, which is what you are studying now, ray optics, we have something which is known as an object, right? Object. So object will either reflect rays of light that will fall on it. So once the object is reflecting, so I would say like that this object emits, I will use the word, I'll use the word emits light rays. The object will emit light rays. Emit means not on its own, it can reflect it also. Emit, or you can use the word, you can also use the word reflects light rays. And when it is emitting or reflecting light rays, then these light rays are going, and these light rays must be going and hitting what is known as a reflective surface, which in our case, right? So let's have a nice object. I'm fascinated by him today. So Shreyas is emitting light rays. So this is Shreyas. Okay, there's our friend Shreyas. He emits light rays, and that goes and hits reflective surface, which is nothing but his, say, his vanity. Vanity is the word used more to a lady. So that's his dressing mirror in front of which he is dressing. And what will happen after this? From this particular reflective surface, we will have the origin of what is known as reflected rays. Is the story getting clear now? So here is your body. Your body is emitting light rays. These light rays go and fall on a reflective surface, which is his dressing mirror. And the dressing mirror, being reflective, will now emit what? Reflected rays. And these emits light rays, we can give a better name out here. We will give the name as incident rays. Incident rays. And these incident rays are incident on this reflective surface, and the reflective surface reflects the reflected rays. Have you understood? Now these reflected rays can, now here is where you need to understand, these reflected rays have to be made to meet. They have to meet. Now when they meet, maybe a little bit difficult as of now, but as 2 or more classes goes, you'll understand. They can meet actually, or may be made to meet. कुछ करेंगे हम लोग, some adjustment we will do. Either they will meet actually, or they will not meet. We will do something to make them meet. Now what is sir trying to say? If my reflected rays are like a shaped, then they do, obviously they'll meet. But if they're in V shape, they will never meet, right? So if they don't meet, we have to do something. Why we have to do something? Only when they meet, then you will get an image. If they don't meet, we will never get an image. So please understand, step by step. In order to get an image, even when you see yourself in the mirror, reflected rays from the reflective surface have to meet. They can meet on their own, and if they don't meet on their own, we have to do something to make them meet. So if I don't do that, then you don't get an image. As simple as that. Yes, Bitu. No, it's not like that. No, not like that. Not shadow, no. Even an opaque object, you're calling it an opaque object, means it is reflecting. It is reflecting. No, that is you are not able to see the object properly is because of intensity of light. At night, if you are walking dense in a forest and a buffalo is also walking and there is no light source, that is eyes also doesn't glitter. All you're gonna do is just go and embrace the buffalo. Yes or no? If you go to villages and all where there is absolute darkness, it's a moonless night, right? Then darkness. I don't know whether you have seen that sort of darkness. जिसको कहते हैं ना घुटघुटा अंधारा. It's like that darkness. And if only there is light. Have you seen in forest and all? Sometimes a cat comes in front of your car, so his eyes get lit up. So there is no light source. Then all you are going to do is that you're going to hit that buffalo or something. That is a different thing. Let's understand this thing, that whenever an object emits light rays, these light rays will go and hit a reflective surface. After they hit a reflective surface, these light rays have to meet. Sir, they may not meet, no issues. In that case, you don't get an image. But if you want an image, by hook or crook, sam, dam, dand, bhed, jo bhi karo, you have to make them meet. Understood? We will keep this discussion a little bit here and try and understand one more concept, that the light rays can be of this order. In such a case, we bring the English word, they converge. So these rays, I will call them as convergent rays. इनके साथ तो कोई problem नहीं है रे बाबा, ये तो meet करेंगे. However, you can have light rays. Yes, see, you are getting the words on your own. In English, we say they diverge. So such rays will be known as divergent rays. The problem will come with divergent rays. How do you make them meet, right? So question is, sir, will divergent rays give me images? Yes, they will give me images. Now, one more small thing and I'll release you today. Here there is no doubt. These rays, you always know, they will actually meet. Is there any confusion? There's no confusion. They will actually meet. These will be made to meet. That means you'll do some sort of manipulation. Okay. When they actually meet, in both cases, once you get the word meet and meet, it means image is there. We will get an image here also. We will get an image here also. But we will add some adjectives. What is an adjective? Something that defines the noun. So here we will say, this will be a real image. This will be a virtual image. That means this word which I use, which was very, very crude, here I'll say they will virtually meet. अच्छा, now I have to use a Hindi word. You have to permit me. जैसे हम हिंदी में बोलते हैं, आभास है. I feel virtual. Some things are there which are virtual and which are not. We say that what is the exact English word? Tangible. Cricket bat. Can I touch and feel it? Profit of my business. Can I feel it? Sadness of your mind. Can I feel it? Love. Can I feel it? Touch and feel? No. These are all virtual, abstract. Abstract. So when they virtually meet, actually तो meet नहीं करते हैं, आभासीय है, हमें ऐसा लगता है कि वो meet कर रहे हैं, क्योंकि we will make some manipulation and make them meet. In such a case, the image that you will get are known as virtual image. We will visit image once again, but to take the story further, you need to have some base knowledge of image. So what is an image? An image is an impression due to convergence of reflected rays. The reflected rays can converge actually. I call it a real image. If they don't converge actually, and you are virtually converging them by some manipulation, and that manipulation is not that light does. In your optics analogy, you are doing that. That's why we brought the concept of geometry. When light is coming, it doesn't come, I am a ray of light coming at this angle. This all are our thought process. In that thought process, we will make it meet. Just like we say, this force can be parallelly brought here. This is our concept that we give to understand the object. So we will make it meet, but in that case, the object, the image will be known as a virtual image. We'll stop here now. We'll go slowly. My only request would be, you can read your textbook also, but please observe the video till this much, see it and then come, then only you'll understand. Because from here onwards, if you don't pay attention, then everything will be very tough for you. I am closing the recording, children.